All right, I'm starting. Okay, we are identifying and using angle relationships to solve problems. Adjacent angles, linear pairs, supplementary angles, complementary angles, and vertical angles. Okay, many pairs of angles have special relationships. Some relationships are because of the measurements of the angles in the pair, and other relationships are because of the positions of the angles in the pair. And some are kind of both. All right,
Whoa. Sorry, I'm stressing.
guys, these are adjacent angles.
Wait, did you know that's not a blank on ours? Yes, it is. What are you talking about? Oh, really? No, it's not. It's the same sentence.
Okay, then you don't have to write it. All right, and a common side, but no common interior points. Okay, so they need a common vertex, and they need a common side, so they have to share a ray, but they can't really overlap. So any point that is in the interior of angle 1 cannot be in the interior of angle 2. Okay? So they can't do this. Right? Okay. So let's draw some non-examples. Oh, my brain just died. Okay, so these two kind of share a ray, but do they share an endpoint? No. So this is a non-example. Okay? What about this?
What is this?
We're drawing non-examples.
Whoa.
Okay.
Because I'm human.
Are angles 1 and 2 adjacent? No, because they don't share a ray. Okay. What about this angle and this angle?
No,
Because they share common interior space, they overlap, so they are not. Okay? Okay, so these are no. Everybody got it?
Yep.
Okay, cool. All right, so angle 1 and angle 2 on this picture are adjacent angles. Oh, examples and non-examples. Sorry, I did that already. Oh, here's one. Here's an example. 1 and 2.
Yes.
These two are adjacent. Okay. Sorry, I should have drawn these pictures down here. That's my fault. I forgot that I gave us room for that. Oh, here's some for them. Okay, a linear pair. Why do you think they're called a linear pair? What do they make? They kind of make a line. They make a straight angle. Okay. All right. This is a pair of angles. They're adjacent, and their non-common sides are opposite rays. They form a line. So angle 3 and angle 4 form a linear pair.
what's their non-common side? Oh, so like they just don't share.
So they just go in the
Why would you?
examples are going to appear to be a linear pair.
Okay, so are angles 9 and 10 a linear pair?
No.
No, because we're missing this slice. Okay? Okay? It would have to be 9 and like this one, right? Okay. So not this one. They can be any orientation in space. They can go like this. This is a linear pair. Okay, they can both be right angles. Okay, those form a linear pair. Right?
Yeah?
Oh, because since they're right angles, they're both 90 and 90 plus 90 is 180.
Oh
Boom!
wait, so
So they
does
just have to,
linear
like,
mean that like
equal-
both of them together make like the whole thing?
Well, if their non-common sides are opposite rays, don't opposite rays form a line?
Yeah.
Okay, and isn't this whole thing a straight angle, which is 180
Yeah,
degrees?
so basically the two angles just need to add up to 180 degrees and are opposite
So
rays.
there can only be two angles?
I guess you could have 3 that added up to 180, but they wouldn't strictly be a linear pair, because pair is 2, but you could have like a linear thruple, I
Wait,
guess.
so
So
what was
they
wrong
need
with
to add
9
up
and 10?
What?
What was
linear
wrong with
system?
It's because
Oh.
it had that middle one and that was cutting out
It
the
was-
portion.
So if you had 9, 10, and 11, you could add all 3 of those up to make 180?
But since 11 wasn't a part of it.
Right.
Yeah, it was just like a missing.
It has to be only two. Has to be
Well,
only
to
two.
be,
See, that's the
strictly speaking, to make a linear pair is 2, but you could have 3 angles that all added up to 180, or 4, right?
So
Okay.
11 was just a random angle on the line?
Yeah, we just took a slice out of it, because angle 10 was this one,
Like a pizza slice.
and 9 was this one, and we were missing this. So without that piece, it's not a linear pair. These two weren't even adjacent, actually. Right? Okay. That was a good one. Okay.
Wait, so without the middle angle 11, they still wouldn't be adjacent?
They're not adjacent, so they can't be a linear pair.
With the 11,
They are.
Okay.
Josh Jacob.
With the angle 11, this angle and this angle form a linear pair. Right? I could use the angle addition postulate and add 11 and 10 together, right? And then I would have a linear pair. Okay? Okay. All right, so we are going to tell whether the angles are only adjacent, only adjacent, adjacent and form a linear pair, adjacent and LP, or not adjacent. Okay, go. I want you to use your noggin. Okay, are we ready to talk about them?
Not yet.
Oh.
Thanks.
All right, talk to me about 5 and 6. Yes, these are adjacent and they form a linear pair. Okay, what about
adjacent.
7 and angle TPU? These are only adjacent.
No, linear is not gonna make like a straight.
Oh, I got them flipped. I got them flipped.
Okay?
I think the last one is
All right. Okay. 7 and 8. 7 and 8. Not adjacent.
or could you say neither?
That was not one of the options. Do you see that neither was not one of our options? Okay. Okay, any questions about that? Okay. Okay, so remember that we said pairs of angles have relationships based on their positions or their measures, right? So linear pairs and adjacent angles have relationships based on position. So these were based on position. Okay? Now we are going to talk about some angle relationships based on measurements. So complementary and supplementary angles are related by their measurements. So these don't have to be touching. They may or may not be touching. So don't have to touch. Okay. Boop, 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 boop. Complementary. Okay, let's look at the spelling real quick. Do you guys see that this has an E where we're used to seeing an I? Like a compliment is the nice thing I say about you, right? A complement is your angle who, if you add it to your measure, gives you a sum of 90 degrees. Yeah, the E means 90 degrees. Okay, so if I look at these two, or these three, can you give me an angle pair that adds up to 90 degrees?
A.
90.
A
and B. So angle A and angle B are complementary. I'm a little worried about the adding right now.
It's okay,
Okay, now, supplementary. These are two angles whose measures have a sum of 180 degrees. A and C, so angle A and angle C are supplementary. We have some room over here for some more pictures. Okay, so let's draw a beautiful 90-degree angle. Okay. Can we call this H, I, J, and then can we have a K in here somewhere?
Yes.
Okay, after doing all of that work, I just figured out that it's probably going to be easier if I just number these angles 1 and 2. Oh, you're welcome. Okay, so if I have a 90-degree angle that is being chopped, however, by a ray, like ray IK, ick. What do I know about angle 1 and 2?
They equal 90.
That they add up to.
So angle, they are adjacent, but they are complementary. Angle 1 and angle 2 are complements.
They complement each other.
Okay, they are complementary. Complementary is an adjective that describes two angles that are complements, which is a noun.
Oh, I did not mean to.
Complement, I did, I spelled it wrong, I forgot a syllable. Complements. All right, are you guys ready for another picture?
Yes.
Boop, 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 boop.
These are supplementary.
Okay, here's angle 3 and 4. Guess what I know about all linear pairs?
They're adjacent.
They're supplementary. Supplementary.
All linear pairs are supplementary. Guess what we're going to use a lot in proofs?
Definition of supplementary.
Yeah, you can either call this the definition of supplementary, or if you're like, what is that the definition of, you can just write it out. Okay, so this is the definition of supplementary for your proofs.
And that's the definition of complement.
Well, it comes from the definition of supplementary, that all linear pairs are supplementary. Oh, shoot, no, that's not definition of supplementary, that's the definition of a linear pair.
What? Wait,
Sorry, I will just write down anything you say.
Wait, I
This
don't
is the
under-
definition of a linear pair.
Wait, how? Like, I just don't understand it.
Because all linear pairs are supplementary.
All linear pairs are supplementary?
Yeah, yeah.
Oh.
Sorry, someone said something that was really close to being right and I wrote it down, but it was the other thing. It's a definition of the linear pair. Okay? So angle 3 and angle 4 are supplements from the Supplement Superstore on Missouri Boulevard. That's a joke.
Oh, yeah.
It's a real place.
Yeah,
But it was a...
worked out. I was like, what?
Okay. What would be the measure of the complement of angle F? What measure would I have to add with 59 to get 90?
21.
Water?
31.
31.
31, my bad, sorry. Told you my brain was not alive today.
31 degrees. Don't forget the degrees. We're not doing radians yet. That's a problem for another day. Okay, what would the supplement of F measure? Okay. Okay, so I just subtracted 59 from 180, right? Okay. Can you guys do this one?
Negative.
I love your little orange crush calculator. That's so cute. I haven't seen that color before. We've done it.
63.5 for supplement.
What was it?
Supplement was 63.5.
63.5. Okay, why aren't you guys giving me a compliment?
Is it a negative?
It doesn't exist. Not
Yeah,
applicable.
I understand. You understand?
All right, what's that? You wanted to do a proof?
Yes.
Okay. Oh, sorry. I thought I heard you say you wanted a proof. All right. How do I know that angles 1 and 2 are complementary?
It's given.
It's given. Oh, it's math Christmas.
No.
Christmas for math. We got all this stuff, but now we have to do a proof.
No. Let's keep going.
All right.
Given.
Okay, so if they're complementary, what do I know about the sum of their measures?
Equal 90.
Mm-hmm. So what definition did I just use here? Okay, so I'm a lawyer. I'm making my case. I just used complementary in my evidence, and now I'm going to use it in my justification.
That's given.
Oh, definition.
Okay, definition of complementary.
Why is that not a definition of? Oh wait, no, okay. No. Wait, hold on. Why can't that be definition of adjacent?
Because I didn't say the word adjacent.
Oh.
And not all adjacent angles add up to 90 degrees.
Yes, you.
Like, angle 1 and 2 are just.
Okay. How do I know that angle 1 is congruent to angle 3?
It's given.
It's given. Math Christmas. Okay, so this is an important thing to notice. This just is personal preference. Some people like to vomit all of their givens at the beginning just to get them out of the way. Some people like to use them as they need them strategically. Does it matter? No. So here's the thing. You can't use it in your evidence until you've put it in your proof, right? So there are certain things that have to go before other things. But other pieces of the puzzle are kind of independent of each other. Like, I have to put on my socks before my shoes, right? Okay? Right? Okay? But does it matter if I put on my socks or my undies first? No. But I have to put on my underoos before I can put on my pants. Does everybody understand what I'm saying?
After I put on
I know something what you could do. Like it could be like vice versa. Like
Yeah, I
for
put my-
softball pants, you can put your softball pants on and then your socks, or you can put your socks on first and then your pants. That is true. Because Chris is
All right, we ready to move on?
Oh yeah.
Okay.
about me.
Hello? Hello? How do I know that the measure of angle 1, okay,
Good job, Katie.
okay. So, how do I know that the measure of angle 3 and the measure of angle 2 have a sum of 90?
The definition of complementary.
Compliment.
No, look at it.
Because our right angle.
No, no, no.
No, Jason.
No, no. Whoa. Slow your roll. Okay. Everybody, look at, I have to have used evidence in my thing. You can't just make up stuff. Okay?
Oh,
What line does this kind of look like?
It looks like,
Do you guys see it looks like line 2?
yeah.
Okay, what is the difference?
There's a 3. Oh, there's substitution.
What happened going from here to here?
Substitution.
Okay? So you guys are being very disrespectful. It's kind of disappointing. So we took line 2, we rewrote it with this substitution. Does everybody see it? Yes. Okay, so this is our substitution property. Now, I had to take my congruent angles and say that their measures were the same before I can put their measures into an equation. Does that make sense to everybody? Okay. Yes?
How do you know when to like write it with like if you just said the substitution property or the substitution property of equality?
The substitution, the properties of equality are things that you're doing to both sides of the equation to make an equivalent equation. Like I'm adding 4 to both sides. I'm subtracting 2 from both sides. I'm multiplying both sides by -3. I'm dividing both sides by pi. Right? Okay? The other ones are properties that we use to make equivalent expressions. Whether we distribute and simplify, or we simplify by combining like terms and make a substitution. Did that answer your question?
Yeah.
Okay, perfect. All right, so how do I know that angle 3 and angle 2 are complementary?
Because they make a right angle.
Isn't it?
They equal 90.
They equal 180.
definition of complementary.
Because of the definition of complementary. If they add up to 90, then I know that they're complementary.
Okay, yeah.
Right?
I had the right part.
Okay. So some of these things we're going to use more than once because we can use them going forwards and backwards.
Forwards, backwards, left, right, and upside down. That's what I like to do.
Okay, we call those biconditionals. Complementary. Okay. We're gonna pause. We're resumed. Okay, you gotta pretend like you were paying attention. All right. So, another pair of angle relationships exists between two angles whose sides form two pairs of opposite rays. Or you can think of these as intersecting lines. Let's say two intersecting lines. Okay, so you can't really tell this on yours, but these are different colors. Would you please use your straight edge and do some auxiliary lines to extend these so that they're long enough for you to measure with your compass? I mean your protractor. I said the wrong word.
On both sides, extend them?
Yeah.
And I said yes, I said it wasn't her meeting, but it was relatable, so she was Oh, sorry. It was definitely.
Okay.
Oh,
So go ahead and extend those.
Can you stop laughing? You just went.
Yeah, this is a no laughing zone. This is where Fawn goes to die.
Oh, we're talking about something what happened when she
Was it
like-
fun?
Yeah, no,
Then
it's not.
you can't talk about it in here.
Well, then I can't talk about math anymore.
Oh, okay.
Ooh, you just got yourself into that trap.
I did. Okay,
Or actually, we can talk about
you guys ready? All right, I want you to measure angles 1 and 3 with your protractors.
that. Okay. Wait. Oh, okay. Oh, I know.
Yeah.
1 and 3 are opposite. I got 44.
For angle 1? 144?
Oh, shoot, I got 130. Oh, shut up.
Okay, what did you guys get for angle 3?
Not the right thing. 144, it should be the same,
Oh.
right?
That's so weird.
Oh, wait, I got it.
Okay, what about angles 2 and 4? Okay, so it's not 144.
How did you guys get 144?
All right, did you guys figure out what 2 and 4 were?
No.
This one is 44.
She seriously just got 45?
This one is
No. Really? I don't think so. Am I gonna have to get my protractor?
Yeah. Yep.
Oh my gosh.
It's 145, or wait, 135.
No,
No,
it was
not
it was more than that.
Mine is 30. I agree, Miss.
Good gravy.
Thank you.
I'll use this one since he's not in this one.
Okay, so let's talk about some observations here. What do you guys notice about these two?
They equal 180.
Okay, they have a sum, excuse me, they have a sum of 180. They're supplementary because they are what kind of pair? Uh-huh. What are these two?
They're adjacent.
Same. They're a linear pair. They're supplementary. They sum to 180 degrees.
Awesome.
Okay? What do you notice about these two?
The same.
Yeah, they're congruent because they have the same measure.
Yes.
What do you notice about these two?
They're congruent.
Right? So, guys, look. If these two form a linear pair and these two form a linear pair, don't these two measures have to be equal if they're linear pairing with the same angle?
Yes.
Okay then. So those are our vertical angles. Our vertical angle pairs are the ones that are like opposite of each other. Oh shoot. So these are, where's my pen? These, where's my pen? Okay. These are vertical angles. And these are a vertical angle pair.
Oh no, there's a reason.
Okay?
Yes.
So that's angles 1 and angle 3 and angle 2 and angle 4.
Oh.
Aha. Phenomenal.
Okay, so anytime we have a pair of intersecting lines, we get two pairs of vertical angles. Okay,
Oh god. That's
Now-
for me.
guys, can we write this down, please?
Yes.
The vertical angle theorem says that vertical angles are congruent.
Oh. Is that definition of vertical?
Nope, it's the vertical angle theorem. It can be proven with the linear pairs. We kind of just did that informally, yes?
Does that mean when you like write out the justifications, you could put vertical angle theorem?
Correct. We're going to use that one a lot. Okay, so we're going to name each pair of vertical angles. So what angle is vertical to angle 1?
7.
Yeah. What about angle 2?
6.
Okay. What about angle 3?
9.
What about angle 5?
8.
You might be thinking, what happened to angle 4?
Yeah.
It's in the middle.
Okay, it was rude. It got kicked out.
Aww.
Okay, do you guys see that all of these vertical angle pairs are congruent?
Yes.
Okay. Oh, here's the vertical angle theorem. I thought I forgot to put it on here. Okay, a theorem is not a postulate. Remember, a postulate we accept as true without proof. We don't need any pudding. Okay? A theorem is a statement that can be proven true. If two angles are vertical angles, then they are congruent. So we are going to use our vertical angle theorem to find x. So what do I know about these two angles?
They're congruent.
Because they are vertical angles. So if they are congruent, they have the same measure, right? So I'm allowed to set them equal to each other. So I get 5x equals 2x plus 24. Subtract away the 2x.
X equals.
Yep. Okay. Easy. Okay.
Yes.
Okay, true, false, and we're going to briefly explain. Are angles 1 and 2 congruent?
No.
Not necessarily, but they do form a linear
linear
pair. So we're gonna say not congruent. So this was false, and now we're gonna fix it. Are a linear pair. Okay, what about 4 and 2? Are they congruent? Yes. They are vertical angles. So this is true because they are vertical angles. Okay, what about 3 and 4 are adjacent?
Because they're linear.
Okay. If they're a linear pair, they have to be adjacent, right? So this is true. So they are also a linear pair. Okay, we're gonna give everyone some time to think because I was rushing everybody.
Thank you.
You're welcome. Okay, so this is DEG and this is FEG. Are those adjacent?
No.
Okay,
It's
because,
FEJ.
okay, sorry, what did I say? DEG and FEJ.
They are not.
Okay, so not, but they're right next to each other.
But
Yeah, but
it's not
they're
linear.
linear.
It doesn't create a linear pair.
So what kind of space do they share that is illegal for them to share if they were supposed to be adjacent?
6.
They have common, what kind of points? Interior. So they have common interior points. So this was false. Okay? Oh, this one's mean.
It's false.
It's false.
Yeah, so if you look at GEJ, that's not exactly a straight angle, is it? So that's false. Angle GEJ is not straight. Ooh, this is a good one.
Do you like 6 and 7? True.
How did you guys, you're right, how did you guys figure that out?
Because
Because
the
underneath
other
it's got
one,
the
angle
right
8 is also.
And they
Okay,
are-
so this is a straight angle, right? So this is 180. We've taken out a 90-degree chunk. Okay? So 6 and 7 have to get us the rest of the 90 degrees, right? So these two are complementary. Oops. Okay, and then do angles 5 and 8 have equal measures?
No.
They look like they're across from each other though.
No, because the angle.
Yeah.
Okay, so the problem is this right here, right? Okay, so angle 5 would be equal to this angle, but not to 8. Okay. So, no, they are not vertical angles. Okay, feeling good?
Absolutely.
Is that the end?
Yes.
Hey, Miss Boynton.